If we can't fight aliens, we might as well wage war against these asteroids, eh? Jokes aside, it looks like NASA's recent mission went really well. And the exciting part, we've got some super cool images. Thanks to both the James Webb and Hubble Space Telescopes, we got to see everything about the DART impact. Without dragging it any further, let's jump into the latest details about the impact. First up, combining the best of both worlds, a Webb and Hubble collaboration. Of the two telescopes, Hubble's the older one because it's been around since 1990, but this recent collaboration just proves that old is indeed gold. By using both Webb and Hubble to capture the DART impact, scientists ended up observing the whole scene from all angles. And you know, these scientists, they've just got to know all that happens. Anyway, by combining the different technologies of these two amazing observatories, we had eyes on all that happened when NASA's spacecraft collided with the asteroid Dimorphos. We still can't believe we're already testing to see if we'll be able to throw asteroids off course. Seems like just yesterday we were talking about something hitting our planet out of nowhere, but looks like we won't be going down like the dinosaurs. We've got the tools to crush these space rocks. Up next, why these observations are essential for scientists. We already mentioned how Webb and Hubble operate on different technologies. As such, both proved themselves to be pretty handy in documenting NASA's double-asteroid redirection test, DART. We didn't get the same images from these telescopes, and there's a reason for that. Hubble used visible light, whereas Webb formed the images using infrared light. Using different wavelengths of light to observe the impact helped scientists have a proper look at the size of particles that were created due to the collision. Other than that, it's also helped determine whether the residual dust cloud contained large particles or fine dust. What's more, using both telescopes is great for scientists to accurately calculate the amount of matter that was ejected due to the impact, along with the speed at which it was thrown into space. Making use of all this knowledge, scientists can then try to understand how a kinetic impact like DART can affect an asteroid's orbit. In the event that an actual asteroid heads our way, we'll have all the information we need on our hands to prevent a large-scale disaster. Now for Webb's role in capturing images of the DART impact. Okay, let's begin with what Webb managed to capture of this first ever galactic collision. With Webb's near-infrared camera, we are able to look at the images that show us what happened before impact, as well as how things started to change as the spacecraft made contact with the asteroid. As soon as the spacecraft collided with the asteroid, the camera captured an image of a cloud of material drifting away from the asteroid's dense center. Moving on, the whole thing was kind of like photography, and as things with photography go, you need to have a good setup to be able to capture the perfect image or whatever it is you're looking to capture. The same effort went into adjusting the James Webb Space Telescope to take pictures of the impact. The team had to factor in the asteroid's velocity, and with DART taking weeks to approach its celestial target, they had to plan it as meticulously as was possible. Not to mention how scientists intend to use Webb in the coming months. Principal investigator on the team, Christina Thomas, talked about how it took tremendous team effort for them to pull this off. These images required a lot of intense planning, and it wouldn't have been possible without such excellent coordination. The story doesn't end here though. Scientists are now planning to keep an eye on the asteroid system that Dimorphos is a part of. To do that, they're going to make use of Webb's two very special cameras, the mid-infrared instrument, MIRI, and the near-infrared spectrograph, NIR-SPEC. It's a great idea that they're incorporating stereographic data into their observations because it seems like a pretty ideal method of figuring out the asteroid's composition with even more precision. Coming up, how Hubble helped observe the historical impact. Now it's time to go through Hubble's role in capturing the details of this galactic impact. Where Webb helped us with how things were before and during the impact, Hubble captured images that showed what happened right after the collision. That's not all though, because Hubble also managed to photograph what happened before the two celestial objects collided with each other. What's more, it also captured what happened 15 minutes after DART hit Dimorphos. The images were captured using Hubble's Wide Field Camera 3, and they gave us a perspective of the entire collision in visible light. Now, here's something interesting that astronomers noted. Right after the impact, Hubble's images show us that the brightness of the binary system had increased, and what's even more interesting is that it didn't dim down hours after impact. In fact, the brightness almost remained steady. James Webb, scientists are going to use Hubble to keep monitoring the asteroid system over the next 3 weeks. Some of you might be wondering what's so necessary about continuing to monitor the after effects of the impact. Well, here's the thing. By capturing capturing more images of what happened once the spacecraft hit the asteroid, we'll have a better idea of the sequences of events that took place before, during, and after impact. All of this information is going to play a very crucial role in helping astronomers study what happens when we use spacecrafts of our own to steer asteroids off course. Finally, what astronomers have to say about the whole thing. Of course, you can guess how unbelievably excited researchers and astronomers are with these images and all that they mean. Jianyang Li, who works at the Planetary Science Institute and was leading the Hubble observations, described how he had no words to describe all that had happened before his own eyes. Hubble had captured such amazing details in these images, and anyone would feel lucky to witness such an incredible event. Andy Rivkin, the team leader of the DART investigation team, called it an unprecedented view of an unprecedented event. Now, in other related news, a look at Jupiter's moon Europa via NASA's Juno spacecraft. We haven't had any good pictures of Jupiter's Europa in almost 20 years. So of course, this new image of the moon has everyone quite literally over the moon. What's more, the images show the ice-covered surface of Europa with such beautiful detail that you can't help but be in awe of how magnificent it feels. The images were taken on the 29th of September when Juno was 352 kilometers away from the moon's surface. We haven't gotten such an incredible close-up of Europa's surface since 2000. Back then, the NASA spacecraft Galileo had managed to capture incredible details a mere 351 kilometers away from Europa's surface. This time, Juno inched a kilometer ahead and gave us a spectacular view of Europa's rough terrain. What's more, there's an impact crater visible in these new images. All of these facts about the moon's geology are going to be incredibly useful for the 2024 Europa Clipper launch, a NASA project that aims to study everything about Jupiter's sixth largest moon. Next, the possibility of a NASA and SpaceX collaboration. Looks like NASA and SpaceX are going to join hands for a space odyssey. Both organizations signed the Space Act agreement on the 22nd of September. The entire aim of this collaboration between SpaceX and NASA's Polaris program is to push the Hubble Space Telescope into a much higher orbit than its current position, and that is going to be achieved using SpaceX equipment. With SpaceX taking the lead in such scientific collaboration, we're expecting to see other companies follow suit. The SpaceX rocket they're going to use for this mission is the Dragon spacecraft. So far, we can say it's a pretty innovative way of exploring how far private-public partnerships can go in the aerospace industry. It's full of promise, and we've already seen that when it comes to science, the best is done when it's done together in a team. Depending on how successful this mission goes, we might end up witnessing more collaborations like this in the near future. For now, it's a great way of solving various challenges, and it means NASA is open to the idea of such missions. Finally, new Hubble telescope images explain why dwarf galaxies around the Milky Way still form stars. For decades, we've heard of astronomers puzzling over the mystery of two dwarf galaxies, large and small Magellanic clouds orbiting the Milky Way. The mystery here is that the Milky Way has been absorbing all the gas from these two tiny galaxies. That's a mystery because, without gas, you can't expect any galaxy to ever form stars. Yet, these two still continue to give birth to stars, and that had astronomers scratching their heads. Well, no more, because these images captured by the Hubble telescope kind of explain why these galaxies have been forming stars despite the Milky Way greedily absorbing all of their gases. In the images, scientists pointed towards a cosmic shield, which they're calling Magellanic Corona, that seems to be protecting these two galaxies. This shield contains supercharged gases, and by offering its protection to the two dwarf galaxies, it's helped them to keep forming those stars. You discover something new every day, for sure. That's a wrap for this video. Have you seen all the images of NASA's DART mission? Let us know in the comments below. Make sure to give this video a thumbs up and subscribe to our channel for more videos like this. See you in the next one.